TensorFlow is becoming one of the most popular tools in machine learning these days, especially and in particular because it helps apply techniques such as neural networks to data with features such as images or video. The question that I'd like us to think about during the course of this video is, why are features such as images or video much harder to work with than text or numbers? Let's revisit this question at the end of this video. Let's say that the classification problem that we are seeking to solve is to classify animals. Now, for instance, let's say that we need to classify whales. We want some kind of procedure which tells us whether whales are mammals. Mammals are defined technically as members of a certain order of the animal kingdom, or whether they are fish. Now, one could make a plausible argument for whales being either fish or mammals. On the one hand, technically they do belong to that infraorder Cetacea, so they are whales, but they also look like fish, swim like fish, and move with fish. One approach to classifying animals would be a non machine learning based approach. You should know that non machine learning based approaches are often called rule based or expert based, and we shall see why in a moment. In such an approach, we would start with an animal, that's a whale, and then we would pass it into some kind of classification system. This would be based on a bunch of rules. The obvious question then is, where do those rules come from? And the equally obvious answer is, they come from the minds, from the combined judgment of human experts. This approach has worked well for many use cases for decades, maybe centuries. The basic idea here is that all of that domain knowledge, in air quotes, is embedded in the brains of these human experts. They just know that a whale does belong to the infraorder Cetacea. Let's now try and understand how a machine learning based classifier would go about the same problem. The human experts here would have a far reduced role. This process would begin with a set of attributes being passed into the system. Those attributes could be stuff like, this is an animal which breathes like a mammal, it gives birth like a mammal. This time, our classifier is a machine learning based one, so it does not have a panel of human experts to consult, but it does have a corpus of data. And this is why having a large amount of data to train your machine learning algorithm on is so important. The classifier will refer to all of the examples in that corpus, and if you've set it up correctly, it will conclude from comparing your set of attributes to the attributes in the corpus that a whale is a mammal. In a binary classifier like this one, there is still a large onus on you, on the person implementing the system. That's because if you direct your machine learning based classifier to focus on the wrong features, it's going to produce the wrong output. In this example, you as the person architecting the system still needed to know enough about whales to tell your system to focus on how it breathes and how it gives birth. Let's say that you were not so smart. Let's say that you gave your system the wrong cues. You asked your system to focus on how this animal moves and what it looks like. It is entirely possible that this algorithm will suggest that this whale is a fish, i.e., it would arrive at the wrong conclusion. The set of attributes which we are going to tell our machine learning algorithm to focus on are called the features. In the image classification algorithm that we will implement in TensorFlow, the feature or the feature vector is the image itself. It's in fact a matrix of pixels. Selecting the right features is a very important part of setting up a machine learning system correctly. The other really important part is training the machine learning system with a corpus with a large set of examples. The corpus must be large and representative, and what's more, it also should consist of the correct features. This is where your role as an expert does come into play, even in a traditional machine learning based system. For instance, you as the expert needed to tell your classifier to focus on how the animals breathe and how they give birth, rather than on how they moved or in what environment they lived. As we shall see in just a moment, an important advantage of deep learning systems like TensorFlow is that they take even this responsibility partially off of your shoulders. Deep learning systems will on their own go ahead and pick the correct features, the correct attributes of our data to focus on. Now, before we get there, let's clearly understand the difference between ML based and rule based classifiers or algorithms in general. ML based algorithms are dynamic because they change their working based on the data that they operate on or that they are trained on. Rule based algorithms are static because, by definition, they are based on a set of rules, much like the constitution of a country. That set of rules has been drawn up by a panel of experts. Those experts have had years, maybe decades of training with a large amount of underlying data, and that's why they bring up those rules. The consequence of this is that experts are somewhat optional in a traditional ML based system. They are most definitively required to build a good rule based system. The experts are optional, but still only somewhat optional in a traditional ML system because they still have a role to play in selecting which attributes, which features the ML classifier ought to focus on. The experts have presumably spent a lot of time examining a large number of data points. The machine learning algorithm has not had all of those years, maybe decades of experience. So, what it does need is a corpus, a large set of data points which it can use to train itself. The size and quality of the corpus is extremely important in determining how good the machine learning algorithm's performance is. Just as a human expert needs a certain length of time to learn the craft and acquire judgment, a machine learning based algorithm also explicitly requires a training step. This is almost always the case, by the way. There is an asterisk here because not all machine learning algorithms require a training step, but virtually all of them do. And conceptually, it is an important part of the working of an ML algorithm. As we shall see, this training step is extremely important when we are implementing our models in TensorFlow. This is where the model algorithm, which we have previously defined, changes itself or tweaks itself on the basis of the corpus of training data that's passed in. We've now clearly understood the difference between rule based and machine learning based systems. These apply to traditional machine learning based systems, which are a bit different from deep learning systems, which we are going to talk about in just a moment. Even so, there are a few terms which it's important for us to get really straight. So let's cover those. The set of attributes that we told our machine learning classifier to focus on, this set of attributes is called the feature vector. The term vector usually refers to the fact that there are multiple attributes. In a complex system, this feature vector can get very complicated indeed. Now, the output of a classifier is a label. For instance, here the label told us whether the instance passed in was a mammal or a fish. Labels and feature vectors are important terms in classification. In most classification algorithms, the labels are fixed. These are drawn from some categorical variable, and the values of the label will not change while the values of the feature vector are chosen by you. In our example, you might choose a different feature vector. You might tell the system to focus on how the animal moves, but the label would still need to be a fish or a mammal. That's the set of labels, fish and mammal. That's the set of labels which our classifier can choose from. The idea of output labels is somewhat specific to classification problems. When we discuss regression, we shall see that the output there is not a label, rather, it's a number. But the idea of a feature vector is incredibly important and it's quite general. It applies to all machine learning algorithms. The attributes that a machine learning algorithm focuses on are called features. Typically, we will pass in a data list in which each data point is represented as a vector of such features, and that forms the input into the machine learning algorithm known as the feature vector. Next, we'll talk about what makes deep learning systems like those built in TensorFlow so special. In traditional ML based systems, it is still experts who have to decide what goes into the feature vector. They are the ones who decide what features the algorithm should pay attention to. There is another class of machine learning systems known as representation learning systems, which figure out by themselves what the important features are. Let's talk next about deep learning and understand exactly how this process plays out. Let's return to the question we posed at the start of this video. Data formats such as images or videos are much harder to work with than text or numbers. And the reason for this is images or videos already represent complex representations or encodings of the underlying data. To extract the correct feature vectors to focus in on those features, those parts of the images or the videos which actually matter, requires much more expertise than working with text or numbers. Consider, for instance, that virtually anyone has a good way to summarize a set of numbers, maybe using an average or a standard deviation. On the other hand, if I were to ask you to summarize numerically the contents of a photograph or a video, you'd probably struggle. This is why data formats such as images and videos require tools such as neural networks. Neural networks can figure out for themselves what really matters, what the important features are. With text or numbers, it's much easier for human experts to zero in on the feature vectors that really work.